Let us see another example. The x coordinate of P is twice its y coordinate if P is equidistant from the point P and R. Find the coordinates of P. Now, let the coordinate of P be 2y and y. Why we are taking the coordinate of P like this? Because in the sum it is given the x coordinate of P is twice its y coordinate. So we assume that the y coordinate of P be y. So the x coordinate is 2y. If the y coordinate is 6, then the x coordinate will be 12. Okay. Now it is given that P is equidistant from Q and R. So PQ equal to PR, it is given. We simply apply here the distance formula and we get this line. From this, on squaring both sides, we get this line. Then after removing the brackets, we get this line. Then after cancellation and simplification, we get the value of y is 8. So the coordinate of P is, what is the coordinate of P? Y. What is the value of y? 8. And what is the value of the x coordinate of P? P, that is 2y, that is 16. The next sum here is point A, B lie on a circle with center O. Find y and the radius of the circle. Now first we draw a diagram. A circle with center O. The coordinate of O is given and A and B are 2 points on the circle with this coordinate and this coordinate. Now we know that OA equal to OB as both are radius of the circle. Now by applying the distance formula, we get this line. After simplification, we get a quadratic equation in y. Now, after breaking the middle term, we get the value of y as -1 or 7. Next, we do if y is -1, the coordinate of O is 2 and 3 and the coordinate of A is -1 and -1. Now, we find the radius OA. We simply apply here the distance formula and we get the answer as 5 units. Now, the second case, if y is 7, then the coordinate of O is, see here, we are simply putting the value of y as 7. So the coordinate of O becomes 2 and -21. See here. And the coordinate of A is, what is the coordinate of A? -1 and y. So if y is 7, the coordinate of A becomes -1 and 7. Now if we apply the distance formula, we get the answer as √793 units. Now the next sum is prove that the points are vertices of a isosceles right angle triangle, and at the same time we have to find the area of the triangle. Now the 3 points which are given as A, B and C. We name their 3 points as A, B and C. Now simply by applying the distance formula we find AB, which is 5 unit. We find AC, which is square root 50 units, and BC, which is again 5 units. So from here we see that AB and BC are in equal length, which is 5 unit. So from here we can say that the triangle is an isosceles triangle. What is the meaning of isosceles triangle? This means a triangle whose two sides are equal in length. Now we can easily see that AC square equal to AB square plus BC square. See here, AC square, that is, what is AC? Root over 50 whole square equal to AB square plus BC square. So we can easily see this. So by applying the Pythagoras theorem, we get that the triangle is right angle at B, because AC square equal to BA square plus BC square. So the triangle is a isosceles right angle triangle with right angle at B. Hence proved. Now what is the area of the triangle? Half into base into height. What is the base and what is the height? Half into BA, that is 5, and again height, which is 5. Now the answer is 25 by 2 square units.